Today we are going to discuss the streaming data platform and data lake, and from the question of does it really work together, and if yes, how? Let me start by a reminder of the last meetup for those who were not able to join. So last time I was discussing the fact that we are shifting in the way we interact. We need more and more real-time interaction. Whether it's on B2B or B2C, you need to have a customer engagement or your client engagement in real time, whether it's in insurance, telecommunication, energy, retail, you need to have this interaction. But if you want to do that, well, it opens the door to new opportunities. And if you like a bit more detail about this kind of business opportunities, you can ask a few questions on them, and Carmen can answer you specific things about that slide. But just know that this kind of interactivity and new way of working will open opportunities in telecom, healthcare, energy, as I told you, in retail as well, in banking. There are many different use cases and many new opportunities opened by this kind of new way of working. But to do that, you need to have a shift in architecture. You cannot just do like before by collecting the data, storing them, and then analyzing, finding insight, and then reinjecting them days after into your application. In this kind of context, the value of the data depends on the time when it is processed. So as soon as you process the data, as soon as you can extract the insight, well, as high will be the value you get outside the data. And that's why, well, the architecture to support this kind of architecture, to support this kind of way of working, of interactivity, needs to be completely redesigned. Interestingly, there was a post last month by McKinsey on their architecture post, and they were writing a post about how to build the data architecture to drive innovation. And they were mentioning 6 shifts to create a game-changing data architecture. And what is really interesting here is that 4 of these 6 shifts can be implemented using a streaming data platform. The first one being the most obvious one, from batch to real-time processing, from point-to-point to decoupled data access, from an architecture warehouse to domain-specific architecture, and from rigid data models to flexible one. If you want to discuss one specific point here on this kind of shift, don't hesitate to ask a question, and then we can discuss specific point at the end of the presentation. Notice that I propose to have the point 5 as the next topic. You will see that at the end of the presentation, we will have to vote for the next topic to be covered. And one of the topics I propose will be the number 5 here, because I think it's a really interesting topic at the intersection between domain-specific development and data architecture. So the last reminder, because it's a really, really important concept, we saw what we called the table streaming duality. And I explained that if you have a data source, whether it's an operational system, a database, a server, or even a device, if this element can send you data, the stream of data can be processed by using stream processing systems like Spark, Flink, or Kafka. But within the stream system, you can materialize this stream of data as a table, and this table can be used by your microservice architecture, things like Spring Boot, Amazon Lambda, or any kind of microservice architecture. Or you can decide within your stream processing system to write this table on file or on database. And then you can find the traditional way of working in batch using Teradata, Oracle, Cassandra, you name it. And then you can apply your traditional data pipeline in batch after this sync table on file. So it's really the basic concept of streaming data. You have data sources. You can stream data using streaming systems. And within the stream, you can still consume in stream into materialized table into the streaming system, or just writing the table on file. And this basic concept will help you to design a company-wide and enterprise-wide data architecture. Okay, so let's start by the first big topic of today. What about data lake? And what are the requirements of your data lake? And as you know, I'm an architect. And as an architect, I prefer starting by listing the requirements of your data lake. So let's go forward. Let's see what you need. What are the functional requirements when you need to build the data lake? The first obvious one, of course, is the storage, and especially the historical management. You need to store the value of a table, but also the different value and different version of the value. So you need to maintain an history of your data. On top of that, you need to be able to delete completely a data in the entire history. It could be a delete or it could be anonymization. A second requirement will be the exploration. You need to be able to explore the data or to plug any kind of visual tool. It could be Tableau, ClickView, whatever, on which you can connect via, for instance, a HDBC connector to be able to explore the data. And if you would like to really be able to explore the entire data lake, well, you need to be able to be integrated or to integrate a metadata management tool, something like Collibra, IBM Infosphere Catalog, any kind of tool that enables you to have data lineage, the link with the enterprise data model, to tag the data, to explain the meaning of the data, so all the metadata management feature. And finally, to be privacy by design. And if you project what does it really mean to be privacy by design compliant on data lake, at least the minimum feature you need to implement are first the GDPR delete, to be able to delete a specific user, and to manage the access policy management according to the different data processing agreement and the purpose of the query or of the application. And of course, to be encrypted at rest. So these are the basic needs to support. And we were discussing that part into the poll, what you need to feed from the data lake. Well, indeed, you need to feed the enterprise data warehouse. Usually is the most significant consumer. You need to feed application and business services, and sometimes you need to feed these applications in real time. Think about the application, for instance, that is on your mobile phone, on which you can apply an instant payment. Well, you need to be able to see directly that your balance has been updated, or every time you enter in a branch of a bank. Well, you need to be able to, as soon as you go out, to be able to trigger somewhere an application that will make a kind of customer evaluation. So you need to be able to react or to feed at least application in real time. You need as well to be able to feed machine learning pipeline. In the same way, sometimes machine learning pipeline need to have real-time feed. Think about things like incremental learning or online learning, or even the new generation of machine learning algorithm like the reinforcement learning need to have a real-time stream of data. So how to feed them from the lake, by the way. This is the things that you need to do. And finally, there are some questions about should you need to do that. So the first one is about qualified data. As you know, some systems are treating today the data according to different level of quality. So in the Gazoo, for instance, we have this naming convention on bronze, silver, and gold. Bronze, for instance, are the raw data, the data that arrive directly from the operational systems. So they are not cleaned. They have the same level of quality as the operational systems, and they have the same schema. From this bronze data, what we see usually is to have a data quality process outside of the lake that can pull data in that process. It could be, for instance, Informatica, DIDQ, any kind of data integration, data cleaning tool. And this is where you do typical things like deduplication, like completing the missing value, defining which value are completely out of range and correcting them. and then to be able to have a clean version of your input data. But this clean version of the input data sometimes is interesting to keep it on the lake as well, because you need to have this historization of this clean data. Then you can re-inject this clean data in the lake, and they are tagged as silver data. And if you use silver data for machine learning, and out of this machine learning, you create new information, for instance, segment of customer, for instance. The segment of customer cannot be created out of aggregation of bronze or silver data. It's new information that tagged as gold data. So by this simple tagging system, you can have three kind of virtual container in your data lake, on which you have the bronze, the raw data, the silver qualified and clean data, and the gold, the insight created out of the data. So you can perfectly indeed do that in your data lake, at least storing them in the data lake and having the qualification process outside. The second part is sandbox and experiment on the lake. I think that this comes from the fact that the first data lake were implemented in the Hadoop stack. And Hadoop has this very cool feature and at the same time a flow for data architecture, this feature of combining storage and processing. So in data architecture, it's not so good because it's really difficult to maintain isolation of data, and segregation of responsibilities if you have everything on the same cluster, because then you have your storage, the memory of the company, but you have the processing power for doing things, experiment, for instance, some bunching, on something which is really highly critical. If you look at the architecture which are more cloud native, today the trends is rather to split, actually, to separate processing and storage. For many different reasons, for cost first, but after you can have a lot of benefit to do that. And the last point is exposing data from the lake. Do you need to directly exposing data from your lake? But if you do it from the lake directly, well, you have mainly two issues. The first one is that you apply first an operational workload directly on the lake, which is not really recommended. The second issue will be rather at the schema level. We call that issue in data architecture and data modeling, we call that impedance mismatch. Is the mismatch between the schema you would like to expose to your services and the schema you have on the lake. Because the schema you have on the lake is by definition the schema from the operational system, which are usually not really the right schema to expose to your service. So can you directly exposing from the lake? I would say not directly. And that's why, for me, this one could perfectly be done, the process outside of the lake and then storing the result on the lake, while these two, I would not recommend to do that. If you need to have any additional information on that, you can still ask a question at the end of the meeting. Perfect. So now we have all these requirements for your data lake. And then the first question will be, well, isn't it too many requirements for my data lake? And this is where the architect will play the role of designing correctly the different things. And well, there is mainly two ways nowadays if you would like to have a data lake and distributing data to your consumer. The first one is, I would say, the more traditional way of thinking or designing a data lake. And actually, it comes a bit from the mindset from BI and data warehouse. Because in data warehouse, you have the same approach. You have all your data arriving on the landing area. You transform this data into a data warehouse schema, which is supposed to be the most common data model to feed the different data mart, is a set of commonalities, actually. And from there, you can then create the different data marts. And here, actually, you find back the same approach. You have all the operational system sending the data directly on the raw data store. And from the raw data store, you can build what we call materialized derived view directly from the lake here to feed the data of the different consumer. However, there is two issues here. The first one is that you don't have really a kind of common data model, actually. Why? Because your data lake is supposed to feed any kind of data product, any kind of data use case of application, data pipeline. So, well, you don't really have a set of commonalities. The set of derived view will just explode. And that means that here you are putting an operational workload on the lake. First of all, because the lake here should process, then you should pull and process the right view for each different consumer, and the number of consumers can just explode. And that means that you need to dimension this data lake according to different criteria. First, you need to dimension according to the number of sources, the depth of the history, and then the number of derived view to continuously feed and update. That's the first main issues to have a large-scale data lake enterprise-wide. The second issue is about real-time consumer. Well, as soon as you have this kind of approach, you can simply not feed real-time consumer from the lake. And that forces you actually to have a second path where you need to collect then the real-time event directly through a collector and feeding your real-time consumer. However, that means that you need to maintain a second path with a different technology, and at the end of the day, it's 2 times the TCO, the total cost of ownership, because you have you have a second dev cost, a second running cost. It's basically an additional and a second TCO. If you take back then the list of requirements, well, about real-time here, about feeding application and machine learning pipeline. So it's okay as soon as you don't need to feed them in real time, because then you fail to have this feature. And the second issue will really be in terms of scalability and how you can scale in terms of distribution. And just don't get me wrong, I'm not saying that the lake doesn't scale, but the distribution of the data doesn't scale with this approach. And because it really doesn't scale, and because the lake by definition cannot support a real operational load, this will have interesting side effects. And the side effect actually is that people will have the tendency to not directly attack the lake or tap into the lake, but will tap into existing system having the information. And that will lead to what LinkedIn pointed out in 2015 as a point-to-point architecture. In order, so LinkedIn was presenting that schema in 2015, where they were presenting all the efforts they were leading for the data streaming platform and for the data architecture. And they were explaining that even though they had a relational data warehouse and data lake based on Hadoop there, people had the tendency to tap into system having the data they needed. Why? Because the data lake nor the data warehouse had the right interface and the right capabilities to support operational loads. And this is where the cost arrived, actually. This is exactly because you have this kind of big architecture with every time each system asking in point-to-point the data, that actually it becomes very difficult to create new application. Today, if you look at the cost of creating a really simple AI or data-driven application, you will quickly arrive into the $1 million. Why? Because of the complexity. Because of the complexity of the different data link, and because of the non-fit of your data lake with your application level and for the consumption of your data. In the same way, having a GDPR compliancy will cost, because it's really difficult to control who exactly is using the data and data lineage and using and defining who access to what becomes very difficult. So the approach here, and then the question would be, okay, but how magic is this stream data platform that can directly resolve all my issue? And actually, it comes from a simple architecture principle that will actually unlock a lot of different things. So do you remember when I was speaking last time about this duality between table and stream, that you can transform a table into a stream, and this stream can be transformed into another table later on, applying some transformation? Well, then let's apply this on data architecture. And if you do that, well, that means that your operational system here, whether directly send event or has a database, can then send event to the central collector here. And then the collector can distribute the data to different data consumer. And every single data consumer can choose how to materialize into a sync table or into an internal table the data they would like to consume. And here you have one specific and special consumer, which is a data lake. The data lake just subscribes to everything going through the collector. In that way, you have then, by definition, a data lake. But the positive side effect is if you now look at how you can dimension the data lake. Now the dimensioning of data lake here is only according to the number of data sources and the depth of history. And the dimensioning of the collector here can be done according to the number of consumer here you put there. And now you have split actually these two main dimension criteria for dimensioning, and that will actually unlock a lot of things. The second very interesting point is that now you have the same architecture for batch and real-time updates without having an additional cost. By the way, short comment here. Last week, I was attending the virtual conference of Apache Pulsar, and there was one presentation about streaming, and the guy started by giving its own definition of streaming, and he was starting by explaining that streaming should not be seen as real time, and you should not associate streaming and real time. However, you should think about streaming as a flexible data processing model. Why? Because it enables you to process data in batch and in real time together. So it's a slightly change of perception of seeing the facts, but this is really what it is. Streaming here enables you to have only one path for batch and for real time, and that will be, of course, an economy here in terms of TCO. And this was the approach used by LinkedIn after they explained the issue they had in 2015 by developing the streaming data platform, and this is where Kafka actually was born. But not only, actually. This is the kind of architecture adopted by Dell EMC when they presented the Nautilus project, which is, by the way, becoming a product now. This is as well adopted by Splunk. I suppose that most of you know Splunk, well known for the log aggregation and log management. Interestingly, last October, they acquired one of the two companies behind Pulsar. So for those who don't know Pulsar, Pulsar is the, let's say, the equivalent of Kafka, developed in 2013 at Yahoo Lab and open sourced, I think, in 2016. And there were two companies behind Pulsar, Streamlio and StreamNative. StreamNative for Asia Pacific, and Streamlio for Europe and US. And then they acquired Streamlio here. Why? Because Splunk completely went into the streaming strategy and streaming first. So for those who know Splunk, you can aggregate different logs, and from the logs you can create some views that you can directly connect to your different dashboards for real time or for batch visualization of your logs. And now what they have adopted with Pulsar is a completely stream-first architecture where everything is a stream, and even your query and the view are completely built on stream. So that shows that the industry actually is really going in that direction. And finally, we have adopted this architecture in Digazu as well, on which we have this collector architecture here, then the streaming that will be connected to the distribution. And in Digazu, you're able to ingest everything in batch or real time and distributing here to different consumers. So in the same architecture pattern I've just explained. By the way, if you would like to have any real business use case explained using this kind of architecture, just ask the question at the end of the meetup here, and Carmen could explain you an end-to-end use case on this kind of architecture. Okay, so we promised to have very short 20-minute presentation. So here we went a bit more because of the poll, of course. Okay, so in terms of conclusion, among the 6 shifts to create a game-changing data architecture shown by McKinsey, The good news is that 4 of them can be implemented using a data streaming data architecture. And if you're interested in the next meetup, we can see how we can cover these points. And if there is really one thing I really want you to keep in mind is maintaining 2 paths for real-time and batch means 2 times TCO and 2 times the technological stack. And this is something from the architecture viewpoint we can change. Thank you.
Well, thank you, Sabri. Thank you very much for your explanation. Okay, so the first question arrived just now. It's from Sasha, so I'm reading this question. The need for a resynchronization in the presented architecture. So, for instance, when a consumer lost its connection and it needs to catch up the missed data.
Yes, so very good question. So let me come back on the architecture slide. Let's say high-level architecture. Yes, so indeed, you are completely right. That's something we ask to the collector to be able to do. So most of the technology that can be used today as a distributed and a high-performance collector, like Apache Pulsar or Kafka, are able to maintain a window on which everything that the consumer has missed should be stored. And then as soon as the consumer arrives, the consumer maintains just the right index on which he stopped listening, and then he can just ask the collector to feed from that specific index. You have to know one thing, by the way. This kind of collector, if you look at what a database are, this kind of collector is nothing else than a distributed version of what we called many years before a commit log. A commit log in a database is something that maintains the log of all the query you made, on all the modification you made on a database. And basically, make a copy of a database was just streaming the commit log to the other database. And Kafka has been built with that in mind. Kafka is not a messaging system. Kafka is a distributed commit log. If you look at Pulsar, Pulsar uses Bookkeeper behind the scene. And Bookkeeper is nothing else than something that keeps a commit log of segment of stream. So all those technologies has been built with 2 elements in mind, distributed and then highly scalable, and having the same non-functional requirements as a distributed commit log. And that means that if a consumer missed something because it crashed or because it was not there, as soon as the consumer arrives, then he can directly ask, according to the index number where he was stopping listening, he can directly ask the collector to feed him with the missing data.
Okay, thank you. A second question, which is in fact a double question, if I can say like this. It's about so how to deal with a consumer which is also a producer. So what about a consumer who creates data? Do we create a new database in this case? The question is, are we in this case not replicating data?
Yes, so it's a really good question. We many times we had that kind of thing happening. So a consumer can perfectly be a producer. In that way, the consumer. So you can think about, for instance, let's think about an application that makes a clickstream analytics. So you have an application, a web portal, and as soon as you arrive on the web portal, you just log in. Then we know that it's you. And then we can connect to your data residing on data lake. And then you start clicking, and we would like to have a machine learning algorithm that takes all the clicks in real time, but that takes as well all your customer information from the lake. And from there, we extract some feature, we give that to a machine learning model, and we try to predict the reason of your visits on the website. Well, for doing that in real time, if you would like to avoid to have a remote query from your application, from your streaming system, and the data lake, you need to have the customer profile directly into the streaming systems. How you do that is very easy, because then you can have a consumer, your streaming system, that asks to consume to the user profile. And then you can materialize the table of user profile directly into the streaming system. So it's a consumer because every time an update will arrive on the consumer table, it will be reflected directly on the table materialized into the application. So it's a consumer. However, the consumer here receive as well the clicks from the website, from another source, combine both, and create a new data. And the new data is the objective of the user visit is estimated to be this one. And this could be an information very valuable that you would like to store. And then this new information can be then re-injected in the collector. In that case, this consumer becomes a producer, but a producer with a different type, because the type of the event he produced is now the objective of the visit. But then he becomes de facto the producer. We need to have the same onboarding process for onboarding a new source, but this source is the event sent by the consumer. And you see here, a producer does not necessarily has a database. It could be a producer of event directly. It could be, of course, a database, and then we can have change the capture of some integration agent to get the data, but it can be as well directly an application sending an event.
Okay, thank you. And the second part of the same question is related with data exposure, and is about where is the place of the transfer of the where do we have to transform the data? So is this before the collector or just before providing to the consumer? This is the question.
Yeah, okay. Actually, there is even two sub-questions in terms of genericity of the data to expose, and indeed in terms of transformation. Okay, cool. So first, in terms of transformation, we would like to have the transformation made in between the consumer and the collector. Why? Because we would like to have the raw data store here, the data lake, listening to everything going through the collector here, and keeping then the raw data. If you transform upfront, the raw data will not be raw anymore, it will be transformed data. So in a perfect situation, you transform only here before you sync into the consumer. So when the consumer subscribes to a data topic, he needs to subscribe to the data topic, and he needs to apply the specific transformation that will transform the data into the target data model of the consumer. Okay, but now, indeed, the second part of the question is very interesting. Because when you have this kind of architecture, you have two ways of consuming data. We call these two ways, first, data-centric or application-centric. What I've explained here just now is application-centric. That means that the target data model is really depending of the consumer needs, of the application needs, and that's why we call it application-centric. But you can think about, okay, I don't want to all my application over and over making the same transformation because, well, I have a kind of set of corporate data which are always the same. I have my user referentials, I have my user profile, I have some, I don't know, some financial figures, and these are all my reference data that are always used. But I would like them to be consumable by my application layer. And to do that, usually what we do is that we create this layer of corporate data using the enterprise data model. The enterprise data model is supposed to be the model you expose to most of your application. And then what we do then is that we create one specific consumer here, which will be the corporate data exposer, for instance, or gateway. And then here you will create all your transformation for creating your specific enterprise data model. So the target model here will be the enterprise data model. And on top of that, you can expose an API, a REST API, for instance. In that way, every data consumption that are data-centric, so enterprise data model-centric, can directly use the REST API on top of this corporate data gateway. And every consumer that would like to have an application-centric data model can directly then subscribe here to the data flow, applying its own transformation and have this application-centric model.
Okay, thank you very much. And we have now a question about a product, Apache Beam. and the positioning of this product in the data stream ecosystem.
Okay, very good. So Apache Beam is the implementation behind Google Dataflow. And Beam has this fantastic generic feature that you can have. Actually, it's a generic processor, so you should be able to execute your Apache Beam workflow directly on Google Dataflow or even on Apache Flink on-prem, for instance. So where do you position it here? Well, exactly here, in between the collector and the consumer. We were speaking and discussing just before the last question about how you transform data out of the collector for defining the target schema to consumer. And this is precisely where something like Beam can be applied. By the way, here, it could be Apache Beam, it could be Apache Flink, it could be Apache Spark Streaming. Well, any kind of streaming technologies, distributed if possible. So not something like Kafka Stream, because by definition, Kafka Stream is a bit light to be largely optimized for heavy workload like data management. But any kind of distributed data streaming platform can be used, or data streaming technologies like Beam, Spark, or Flink can be used here in between the collector and the consumer for applying transformation for getting the target schema.
Thank you very much. So the question is, really, could we escape from this database approach and manage events, so Kafka, Pulsar, ETL for materialized view?
Yeah, so not necessarily actually. So you don't. So in the example I just gave you about the clickstream analytics, when I say you materialize the table into your streaming system, you actually materialize the user profile as, to be accurate, as a state into the streaming layer, into a stateful streaming layer. You materialize your user profile as a state. And when you receive an event like a click with an ID of your user, you can then merge easily the state with the user profile with the ID of the click. And then out of this, you have all the information you need to give to your machine learning model. So here, you don't need database at all. The state actually is where you can maintain the data coming from your data source and where you can apply your transformation. So you don't necessarily need to have a database. Going further, you don't necessarily need to maintain everything on the streaming system. If you think about the other extreme, and I think this is the objective for your question, you can consider that the collector maintains a log with all the history. And then every consumer here will be just a view on the log. Well, that's a bit different, because if you do that, and I know that typically some people think about usage of Kafka for doing that, that's a bit tricky here, because this is something I would recommend for Pulsar, but not for Kafka. Why? Because on Kafka, you are still binding the broker with the storage. And that means that you need to dimension the collector according to the number of consumer, and then you come back dimensioning the collector with the history and the number of sources you need to maintain, because you need to dimension the broker according to the data you will maintain. While in Pulsar, it's completely separated. So they use Bookkeeper, and Bookkeeper provides you a level of indirection between the storage layer and the broker layer. So it would be actually a reasonable architecture using Pulsar, but not using Kafka.
Good. We have more or less 5 minutes left, maybe time for so going to the next steps and voting for the next topic for the next meetup.
Okay, let's go for the...
So maybe in the meantime, you may start voting.
Indeed. So, yeah, go ahead.
Already. We have some votes.
Cool. So let me introduce the topic. Then you are sure that you are voting for the right things. So this is, it's becoming a habit now. So at the end of the meetup, we are voting for the next topic. So the first one will be why streaming ETL and stream data platform can decrease your running cost and TCO, and then it's really a focus on cost. The second point comes from the fact that today there are many different offers on the market about streaming data platform, and it's not really simple to choose between what is really a streaming data platform, a data hub, a data lake, data pipelines. So it's not really easy to see the differences. The C actually is a topic that I really love these last months. Is about data management maturity model. A lot of customers we have seen so far doesn't really manage to know where they are exactly. What is the level of maturity they have today? What is the target level of maturity they would like to get? And how from this maturity levels, how to infer, how to derive a data program to define what to put in place step by step to reach the expected maturity. This is something very, very, very interesting. And we studied this topic, and we even consolidated many different existing models into one maturity model, and we are collaborating with some business school, including Solvay, for these kind of things. And the D is really one of the points raised by McKinsey in their post, and it's about from the data warehouse architecture to a domain-based architecture. And that's really at the edge between domain-specific, domain-based architecture and development, data architecture, and streaming together.
Yeah, we have currently a perfect equality between the first and the last one. So please help us maybe to choose. If you can continue vote, please. There are only 6 votes till now. So real cost. So the cost is really a concern for you. So well, this is very clear. But at the same time, you are really curious to understand more about the domain-based architecture from McKinsey. Okay, if this is the result, we are now to reflect on how eventually to proceed further. But we are for sure going to address both topics.
Sure.
And of course, there is also a high interest on the maturity model.
Cool. Perfect.
Good.
Then thank you. Thank you very much. And let's see you together next month then.
Okay. Thank you very much. Thank you to all.
Thank you. Bye.
Bye-bye.